Hello friends, I welcome you all in this session. As you are aware, in previous session we were solving couple of examples on two sample test, and we have worked out couple of examples using probability value approach and critical value approach, and we solved examples using critical value approach, and the answer which we were getting, we verified those answers using Minitab software. Today we will look at some more questions related to two sample hypothesis testing. So, let us look at this example. There is a faculty member who is in fact teaching students using audio visual aids and just normal lecturing method, right. So, there are two ways of teaching methods, either just normal lecturing method or using audio visual aids, right. So, he wants to know the effectiveness of these two methods. He wants to know whether this audio visual method is more effective compared to the normal teaching method or teaching pedagogy. So, what he did, he selected a sample of 15 students and he just took the mean of marks of those 15 students in a subject, and the standard deviation of marks was 19. Now, when the same teacher taught the students using audio visual aids, the mean marks of the students was 92 and the sample size he chose second time was 12, right. Sample standard deviation 15. So, the question is new method more effective? You have to test this hypothesis at 0.05 significance level. So, now you have to frame null hypothesis, alternative hypothesis, then you need to decide on which test you are supposed to apply, whether it is t test or z test. So, the question is very clear, is new method more effective? A new method is audio visual aids. So, how would you write null hypothesis? Null hypothesis is that mu1 and mu2 are same. So, the mean marks obtained by normal method and mean marks obtained by audio visual methods are same, right. And alternative hypothesis is what it would be, mu1 is better method than mu2. So, here we are saying that mu1 is this and mu2 is in fact your old method, right, mean of the old method, right. This is up to you how you are assigning mu1 and mu2. You can have this as mu2 and this as mu1, only the thing is this will change, right. So, this is your null and alternative hypothesis. Now, we have to decide on what type of test you would be applying. So, first thing is very clear that this is a one tail test example, right. So, it is a right tail test, this is the rejection region in right tail test, right. And what about z test and t test, which test we would be using? Sample size is in both these cases less than 30. We have been given sample standard deviation, not the population standard deviation, right. So, we will use t test over here, right. So, let us look at the solution to this question. So, first of all calculate pooled variance Hp square. So, this is n1 minus 1 into S1 square. So, this is standard, this variance of first sample, variance of second sample, first sample size and second sample size, right. So, this comes out to be 301.16 and the t calculated value is 1.19. You need to keep in mind that this term mu 1 minus mu 2 is equal to 0, right. So, x 1 minus x 1 bar minus x 2 bar is simple, you have this 92 minus this. So, t value at 0.05 degrees, 0.05 at 25 degrees of freedom. How come 25? This is n minus this n 1 plus n 2, this is 27 minus 2, right. So, this is 25. This is how we calculated degree of freedom, n 1 plus n 2 minus 2, because you have got 2 samples over here, right. In one sample test our degree of freedom was a different one. Okay. So, let us look at this. So, calculated t value is 1.19 and the table value is 1.708. So, this is our calculated value, t value here, and this is table value, right. Since our calculated value is in this region, right, this region, this side is this side, right. So, we will not reject null hypothesis. So, at the end of the day we will take a decision that we will not reject null hypothesis and we will conclude that both these teaching methods are equally effective. There is no significant difference in the effectiveness of these two methods, that is our conclusion, right. Though the mean looks like that this method is better, but it is not like that. Statistically there is no significant difference in these two methods. And of course, how to look at this t value, this t value, it is 1.708 at 25 degrees of freedom. So, 25 degrees of freedom 1.708. So, look at here. Okay. So, this is actually 0.05, this value. Okay. So, we can in fact work out this example using Minitab software. So, let us use Minitab and work out this example. So, go to stat, basic statistics, it is 2 sample t test, right. So, 2 sample t test. Now, you can have values either in different columns or you can have summarized data. So, we will use summarized data option. So, sample size of first sample is let us say 12, 12, 15, 12, 92, 12, 92 and 15 is the standard deviation, right. Let us look at information about sample number 2. You have got 15, 84 and 19, 15, 84 and 19, right. Click options, you need to test this hypothesis at what significance level. We will go back to the question, it is at 0.05, right, this is 0.05. So, this is 95. So, hypothesized difference is 0, right. Alternative hypothesis has to be more than, right. So, the difference is more than hypothesized difference and you have to assume equal variances. This is one of the assumptions for hypothesis testing. So, OK, again click OK. So, if you look at p value over here, p value is 0.123. In fact, other information is available here, sample 1, sample 2, their mean, standard deviation. So, we are saying that difference is 0, right. This is our null hypothesis. So, p value is 0.123, 0.123. So, p value is 0.123, alpha is equal to 0.05. Is p less than alpha? No. So, we do not reject null hypothesis. So, this is our conclusion using p value approach and using Minitab, right. Let us look at one more question. A consumer research organization routinely selects several car models each year and evaluates their fuel efficiency. In this year's study of two similar subcompact models from two different automakers, the average gas mileage for 12 cars of brand A was 27.2. So, N1 is equal to 12, average is 27.2 and standard deviation was 3.8. This for first sample. Okay. The 9 brand B cars, the 9 brand B cars that were tested averaged this much. So, N2 is equal to 9, average is equal to 32.4 and standard deviation is 4.3. Now, question is, at 0.01 significance level, should it conclude that brand A cars have lower average gas mileage than do brand A? So, what would be the null and alternative hypothesis? So, let us say mu A is equal to mu B, right, average of A, average B, right, these two are not these two, these are in fact sample means. So, we will say that let us say the population means of A and B are same, and can this organization conclude brand A cars have lower average. So, mu A is less than mu B. This is our alternative hypothesis. So, this is a case of again a simple t-test example. So, we have got all this information given to us. So, just calculate pooled variance first of all. So, this is pooled standard deviation is 4.0180. Lower limit of the acceptance region would be this, right. So, how the distribution would look like? It would be like this, right. This is your left tail test, right. So, this is your rejection region, okay, and this is your acceptance region. So, calculate t value is this, which is minus 2.766, and when you compare it, so this is your let us say table value, it is minus 2.53 and this is your calculated value, which is somewhere here minus 2.76. So, this value falls in rejection region. So, we will reject null hypothesis, and when we reject this hypothesis, we will say that yes, mileage of brand A cars is lower than mileage of brand B cars, right. Okay. Or in other words, brand B delivers significantly higher mileage than brand A, one and the same thing. Let us work out this example using Minitab. So, we will go to stat, basic statistics, 2 sample t-test. So, let us look at once again data. So, you have got 12, 27.2 and 3.8. 12, 27.2 and 3.8. So, this is how you should enter data about sample 1. Let us look at sample 2. It is 9, 32.4 and 4.3, 9, 32.4 and 4.3 options. This is a hypothesis which is to be tested at 0.01, it means 99% confidence level, right. So, hypothesized difference will remain same. So, this is a case of left tail test. So, difference is less than hypothesized difference, right. Click OK and OK. So, this is how you should be getting p value 0.004. Of course, your null hypothesis, and this is what your calculated t value minus 2.93 and it is 0.004. So, 0.004. So, p value is 0.004, alpha is equal to 0.01. So, p value is less than alpha. So, we will reject null hypothesis, is not it? That is what we have said when we used p value approach for hypothesis testing. So, using these two methods we are getting same answer. So far we have talked about hypothesis testing of independent samples. Let us look at the hypothesis testing of dependent samples. Dependent sample means you are collecting data from a sample and after some time you are again collecting data from the same sample. Of course, let us say you have collected height of students in the month of January, you find out its mean and you collect again height of all the students in let us say month of December. So, we can see is there any significant difference in these two heights of the same group, right. So, this is a case of dependent sample, we call it a paired sample, we also call it related samples, right. So, either you call it dependent, related or paired, one and the same thing. Only the thing is you just you collect or the repeated measures happen over there, right, before and after. So, the difference in mean would be this. So, d I is the difference. So, x 1 I, x 2 I, similarly you can have x 2, x 3 and so on, right. So, you will have some data set and then after some time, after let us say giving certain stimuli to the group of student, we will again measure height or weight or some other variable. So, you need to keep in mind two important assumptions, that both the populations are normally distributed, and if it is not normally distributed, then we will take large samples. So, this is how you should be calculating pair difference, we have already talked about this. The difference, the mean of pair difference is this. So, this is summation of differences divided by number of pairs and this standard deviation of the paired sample, right. So, d I minus d bar whole square summation of this and under root of this, right. So, this similar to what we have seen in one of very few classes, right. In the beginning we have seen how to find out standard deviation and variance, right. So, paired difference test, this is how you would be using t test if you are using paired hypothesis testing. So, d bar minus mu d divided by h d upon root n, and it will have n minus 1 degree of freedom, right. In fact, when we worked out questions on 2 sample test independent samples, the degree of freedom was n 1 plus n 2 minus 2. but since here there is only one sample, you are just collecting data from one sample before giving certain stimuli and after giving certain stimuli. So, this is how the distribution would look like. So, the direction of sign over here will decide the direction of test, whether it is an upper tail test or lower test, right. So, this is left tail test, and this is how the distribution would look like. This is your rejection region, this acceptance region or non rejection region, right. This is an upper tail test, right. This is your rejection region, and this is a two tail test case, right. So, there are two rejection regions, right. So, you need to again compare the calculated t value with the critical table value, right. Of course, you can solve this kind of problem not only with the help of t value approach, but with confidence level approach as well. So, you can use you will have this mean of differences, you have got t alpha by 2 this, and just check whether the after you will get two limits over here, upper limit and lower limit, and see whether you are rejecting or not rejecting null hypothesis using confidence interval approach, right. So, we will take up this question. It is on pair difference test or related sample or dependent sample. Let us say you are running a company, let us say a service type of business, a service station of automobile for simplicity. So, you are sending your sales people to customer service training workshop. So, you have sent your employees to a training center where they would be learning how to interact with the customers, right. So, you have sent 5 of your sales people for training program, and before sending them on training program, you just measured the number of complaints they were solving. So, this fellow used to solve 6 complaints, E fellow used to solve 4 complaints, and after attending the training programs, you have noted down the number of complaints being solved by these sales persons or sales people, right. Now, this is and you want to know what is there any difference in these two set of data, or has the training program made difference in number of complaints, whether your complaints have gone down or it has gone up. So, what kind of null and alternative hypothesis would you frame? You need to have null hypothesis as, let us say, there is no significant difference, right. So, let us say mu 1 is equal to mu 2, and the other one would be because you want to know has the training program made any difference. So, it is not equal to type, right. So, this is a case of two tail test. Okay. So, mu d, in fact, this how you should be writing your null and alternative hypothesis. So, the difference, mean difference is 0 and mean difference is not equal to 0, right. So, you just calculate the t value first of all. So, d bar would be 4.2 minus 4.2. How did you get minus 4.2? So, minus 4.2. So, this is the difference, 4 minus 6, 6 minus 20, 0 minus 4. So, this average is minus 21, sum of all these differences divided by 5. So, you will get this value as minus 4 by 2. Okay. Once this is known, you can calculate standard deviation as well. So, 5.67 is the standard deviation. Now, let us look at the solution to this question. So, t value is minus 1.66 and table value you need to look at 4 degrees of freedom, because 5 is the you have got 5 pairs, right. So, 5 minus 1 is equal to 4, and t value if you look at table, then it would be plus minus 4.60. So, this plus 4.60 is minus 4 these are your critical values, and calculated t value is in this region. This region is non-rejection region. We do not reject null hypothesis. It means what? There is no significant difference in the mean number of complaints before training program and after training program. In other words, the training program has not produced any result. So, it was just a you can say a futile exercise. It did not reduce number of complaints, right. So, we will work out the same example using Minitab software. So, here what we have done, we are not rejecting null hypothesis, right. So, let us look at data. These are the data set. So, let us work out this question using Minitab software. So, this is first column is before number of complaints before sending employees for training program, and after number of complaints after sales persons have received training, right. So, let us enter data. So, this is 620,304, 620,304, right, and then after 46200, 46200, right. So, you just do this much data entry and then go to stat, basic statistics. So, there is an option here, it is paired test. Yeah, this is paired test, right. So, click over here paired test. Okay, sample in each column, we do not have summarized data. So, we will have sample in each column as it is. Okay. So, now we have got sample 1 which is before. So, click over here and select before and then select, then again after, select this, go to options. We have to test this hypothesis at what significance level, it is 0.01, it means 99%. So, hypothesized difference is 0, we are taking it, and alternative hypothesis is not equal to type, right. So, it is a case of two-tail test. So, we will click at OK, again OK. So, p value is 0.173, just look at this 0.173. Let us compare this with p values 0.173, alpha is 0.01. So, p is not less than alpha. So, we do not reject null hypothesis H naught. This is the decision we took over here when we used critical value approach. So, let me summarize what we have done in today's session. We have used hypothesis testing for 2 samples, wherein we first framed null hypothesis, then alternative hypothesis, then we decided on the type of test to be used, then we calculated t value or z value, whatever was the case. Then we compared the calculated value with the critical value, and then we decided whether hypothesis was to be rejected or not to be rejected. And we have worked out all those questions using Minitab as well, and when we used Minitab package, we in fact used p value approach, and we found that the answer in both the methods were exactly similar, and they have to be similar. If you are not doing any wrong data entry, then you will get the answer, you have to get the answer, because Minitab software it just does calculation. What you can even manually solve a problem, if you enter data properly, then software will give you the same answer, right. So, with this let me complete today's session. We will have some more questions on hypothesis testing of two samples in next lecture. Thank you.